Yeah, now we're going to look into the Simatic. I call it just the Simatic programming model. What do we have? What can we do here to automate our plant? What kind of memory do we have? We can store data. What can we program? What kind of program elements do we have? And so on in the Simatic. Yeah, that was the programming model. Yes. Then we need data storage. We have to store our data somewhere. We need data. We have input data from our sensors, output data to our actuators. We have global memory. Of course, we don't use that, avoid that, because that has been traditionally used for communication between parts of the program. Of course, shun that. Don't use global memory. Maybe you have to at some point in time, but not as much. Avoid it. Static memory. The static memory is memory that, as long as your power your program is running, it keeps the last value you wrote into your memory. And then we've got local memory or temporary memory that they can't remember anything. Use it for scratch purposes. If you do some calculations and you have to save an intermediate result or something like that, use temporary memory for that. And the memory is addressed symbol by names. Even for some memories like input and output data, you can have a physical address that you can access. In TI portal and the newer versions, you can't access it, let's say, with the absolute address. You need to use a name for it, of course. So direct memory access is not something we do in 2024. And then this memory, what kind of data types can they have? The Simatic is byte oriented, needless to say. We have a bit, a bool. It can be a bit, or it can be a bool, where in the byte is hexadecimal 0 false and FF is true, or 1 is true. It depends on how they do this. And here are all the types. You have got a string type, but as the PSC can't speak or read, at least, you can't speak either. I don't know what you want to use your string and character for. Why do you want to store the text in a device that can't read, or whatever? But it is up to 64-bit. This S7-1500 is a 64-bit processor. And then we have some constants too. They are stored in memory, of course, but you can write to constant. And here are some how we kind of write constants. You can look at it in hexadecimal. It's not 0x. It is 16 and a hashtag, for instance, like this. And you can specify binary if you like that. And you have a long, and you have got a time and long types. And there are more than this. Okay, what do we have when we do coding? Now we have got the data storage and kind of figure out, but what can we do to code this stuff? So what with coding elements, we have a task. At Siemens, they call this organization block. Of course, I hope this is going to disappear soon. It's a task. That's the link to the operating system. Operating system can execute a task, and whatever you put in the task is executed. And then we've got functions. That's 1 + 1 is 4 or 3. That's a function. Function block is a class. We program a function block to do a task that needs special memory, information hiding, and all this stuff. And with an interface, defined interface, we can program a function block to control an electric motor or a frequency converter. A frequency converter is in this compendium too, but that's purely for information. And then we have a program where we organize our functions and function blocks. Note, Simatic or TIA portal or Siemens, they don't have this program type. So what you should do is use an FC with no arguments and no output. A void FC would act like a program element in other types of CPUs. Then again, a program element in other CPUs, you can, let's say, instantiate function blocks. You can't do that in an FC in Simatic. Then you would use an FB. So if an option, if you want to do it like this, use multi-instance, use an FB. instead of an FC. But then you will call your, then will be a prefix. We're going to look at it like that. And then you can make instances of function blocks in the static sections of your FB, but it wouldn't have any inputs and outputs, but it could have inputs and outputs. It depends upon you want to do it. But Siemens, they use memory element here, or the data area for function blocks is something called instance data blocks. So they only know data blocks in Siemens. So they don't follow this standard from PLC, but whatever it says. Now, let's see at the programming model itself. Here's a figure. So what we have organization blocks. There's more than one type. There's a lot of them. We have function blocks and functions and code. We don't have this program element, but maybe that should be the innermost blue one here, either an FB or an FC, depends on how we want to do it. And then we got this input we talked about, the data we talked about, and then we've got the IO modules themselves, and the operating system take a snapshot of my inputs and store it in input memory. We take a snapshot of our process state before we process. Very smart to do, so we don't get glitches. Let's say there is an input that changes while I'm processing it, and I assume it's true, and it's changed to false in my program. My program's just a mess. But you can access them directly too, because it's a name, and if you have a :P, then you access it directly from the module if you have to. Input image, it's called. So your program is working on that, and then it does something, and you have to output something to a process. Have an output image, and operating system, when your program is done, says, okay, what's in this memory? Transfers to the modules, and again you can write directly to the module if it has to be fast. Yeah. And then we've got these data blocks we talked about. That's the data storage the Siemens offer, except the local or temporary data. And then they have the global memory. So of course you shouldn't use global memory. If we are writing 2024, have some more safe interfacing between your program modules in here. So that is the programming model, and here is how you specify this absolute addresses. But then you do it in the so-called tag table, where we tag this memory location and we access them using names. I don't know if even if it's possible to access them directly. So here is how this let's say how this input memory is an output memory. This image is organized. So this byte transfers to this walk memory. Your CPU uses it, and so on. So sending number starts at byte 0. You can specify, let's say, what byte this module is going to be located at. Usually we start with the binary input starts at 0, and depending on the CPU, we have so and so many bytes for inputs. And it's the same, the output can start at the same address because they're separate areas. These outputs at 0, and some are down here. If you've got analog, they start down there, and with smart instruments further down, and so on. There's quite a bit of memory available here. The AI, analog inputs, input image, they are 2 bytes. And analog input in Simatic is 2 bytes, 16 bits. Analog output is the same, 16 bits. Operating system does this transfer. And remember, if I have an analog input channel with byte X and X plus 1, the next channel is not X plus 1. So if I have an analog input at 256, occupies byte 256 and 57, and the next channel starts at 258, and if you try 257, you'll get half of 2 channels. You're going to get the worst part of 2 input channels. It's the same with the digital output. And then we have got the data blocks, is the data storage. They can be of 2 types. An instance data block that's assigned to, they store the static data. 2 types, one that's assigned to a function block and one that is for you to use for whatever you want data you store. So here's function block and instances. We have a function block, roughly a class. We have instance data blocks. We use the same code or more data blocks, and so on over here. So we have a lot of function blocks. So PLC, modern PLC program is about programming function blocks and interconnect them and do whatever your control should do, and get rid of FPD and ladder And if you want to use ladder, God forbid, this combinatory logic, use ladder and not FBD, because it's easier to follow the power flow than decoding complex and or a not and so on down here. But of course, avoid it altogether. It's not necessary. Then we have got these tasks that we talked about, organization blocks. There are few types. We have cyclic, which is usually that's one that's executed all the time. Kind of more of those. Execute the program, read the inputs, restart, or read the inputs, execute the program, write to outputs, restart, read inputs, execute program, blah, 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 blah. Cyclic. Time control, do the same, but every hour. Interrupt control, do the same, but wait for a deal input or handling, deal input to change and handling input to exceed a limit or something, and do whatever you should do. And then you've got this bootstrap program. Let's say, okay, when you PLC, you input power on your PLC, you can execute these a task that's executed. So what kind of initialization you need to perform, put it in these tasks before your program starts. Of course, in an object-oriented environment, this is just nonsense. The startup has to be the object itself that needs to know that it's the first time I execute, either because I'm instantiated and loaded down into my PLC, or the power is gone and the power has been switched back on, and I have to start to do something. What should I do now? Basically, what you do is you have a look around you, and what does it look like around me? I'm controlling a motor now. Is it running? Yes, nice. And then I am in the state running. Is it stopped? Okay, nice. I'm in the state stopped. It's not running, it's not stopped. If you have two feedbacks, better with a valve. Do something. It's the objects, instance of function blocks that need to know this restart. So this is pretty much, but you can do it too, because this instance you could call them in the starter too, and then you call them somewhere else. But usually you want one invocation, one call up over instances. Function and function blocks, similar in structure. In Simatic they are. The main difference is functions can't store static data. They have temporary data only. They have input outputs, and output data. And a function should basically have just one output. It's a type data output. But Siemens, you can have a lot of individual outputs, but maybe you should the data type and say this is one output. It's a structure, contains 4 booleans and whatever, and a value, something like that. This is input output data, temporary data, scratch pad, static for function blocks, and input output data. That's what we have. And here is what it looks like. In Simatic, input output data for the basic types, they have stored an instance data block. If you have a structure or something, they are accessed by pointers. You don't see the pointers. The operating system handles the pointer. And static data and temporary data is special memory in your CPU. Yeah, that was pretty much so what we looked at was the programming model for Simatic. We looked at the data areas. We got inputs from sensor, outputs to actuators, the instrumentation that we are working on in the plant to get something to happen. We have data blocks and the program element. Yeah, we have organization block tasks. We don't have the program element that you should have. Use an FB. Depending on if you want to use multi-instances and let's say template propagation from your library, use an FB. Or use an FC to do it. Yeah, what more? Yeah, we looked at functions and function blocks, and they're pretty similar. And the function has no memory. T has a goldfish memory, and the function block has a little more memory. So the function block data is stored as long as you have power on the CPU. You can retrieve those. If you switch off your CPU and back on the power, you get initial data, but if they are retained data, then you get what you saved before you switch the power off.